Hello everyone, this is Chandrasekhar, a mechanical engineering graduate from IIT Delhi. So guys, today we are going to discuss very important and very interesting topic of physics, that is projectile motion in detail. Because projectile motion is such a topic which the concept of which can be used in so many other topics. So projectile motion is basically two-dimensional curvilinear motion. So let us first talk about the two-dimensional motion or motion in a plane. Then we will gradually move to the concept of projectile motion and we will discuss some problems as well. All right. So if we talk about two-dimensional motion, or we can also call it as planar motion, when the particle is moving in a plane. For an example, if I talk about XY plane, this is x-axis and this is y-axis. Initially, there is a particle which is at a location, let's say A, which is having the coordinates x comma y. So the position vector of this particle will be xi cap plus yj cap. You must already be knowing from the concept of vectors. This is, let us say, RA, position vector of A. So position vector of A can be written as xi cap plus yj cap, right? In some time delta t, the particle has moved to some other location. Let us say it has reached to location B in time delta t. So the coordinate of this particle can be taken as x plus delta x, comma y plus delta y. There is a small change in x in some delta t time. There is a small change in y as well. So the particle will reach here. The position of the particle, the new position of the particle can be taken as RB. So we can call RB to be, we can say the position vector at point B will be x plus delta xi cap, then y plus delta y j cap, isn't it? Now the particle is following this path, let us say. In time delta t, the particle has taken this path to reach at the new position, that is point B. Now the analysis of such motion, that is two-dimensional motion, there is a motion of the particle along x-axis also, there is a motion of the particle along y-axis also. So this two-dimensional motion can be easily analyzed by two methods. Method number one is vector approach. Let me quickly talk about the vector approach, then we will discuss about the another method. Method one is called as vector approach. If you are very much comfortable with vectors, then you can use this concept, vector approach. The change in position of the particle is known as displacement. So we can say change in position vector, that is RB minus RA, that is the displacement vector, that is delta xi cap plus delta yj cap, isn't it? Or if we take the time to be infinitesimally small, then we can say for very, very small time, we can say change in position is equal to dx I cap plus dy j cap. This is called as displacement vector. We can call it as displacement vector. All right. Now displacement per unit time or change in position per unit time will be the velocity vector. So the velocity vector can be calculated by differentiating this position with time. So which will be dx by dt I cap plus dy by dt j cap. Dx by dt is velocity in x direction. We can call it as Vx I cap plus Vy j cap. This is the velocity vector. Dy by dt is velocity along y direction. Differentiating this velocity vector will give us the acceleration vector. Let me write it here. The acceleration vector is equal to change in velocity per unit time dv by dt, which can be called as dvx by dt I cap plus dvy by dt j cap. So we have calculated the displacement of the particle, we have calculated the velocity of the particle, we have calculated the acceleration of particle. This dvx by dt can also be written as double derivative of x, d square x by dt square. Similarly, dvy by dt can be written as d square y by dt square. Differentiation of dy by dt, that is differentiation of velocity with respect to time. Now, from here there are some possibilities. Look, we have talked about the acceleration vector, we have talked about the velocity vector. Yes, we have talked about the acceleration vector, we have talked about the velocity vector. Now, between this acceleration and velocity vector, the angle is, let us say, theta. The angle between the acceleration vector and velocity vector is theta. Now, if the angle between velocity vector and acceleration vector is either 0 degree or 180 degree. What is the meaning of 0 degree angle? The angle, when the angle is 0 degree, it means, when the angle is 0 degree, it means velocity and acceleration are in same direction. Velocity and acceleration are in same direction. When they are in same direction, it means there is a accelerated motion. This is called as accelerated motion. What is the meaning of 180 degree angle between acceleration and velocity? It means the acceleration is opposite to the velocity, right? So this type of motion is one-dimensional motion. Why? Because the direction of velocity, the velocity and acceleration both are along the same line. So it is one-dimensional motion, or we can call it as rectilinear motion. So when it is 0 degree, that is accelerated motion in one dimension. And when it is 180 degree, then it is retarded motion in one dimension, right? Now, if the angle between velocity vector and acceleration vector is 90 degree, what does that mean? Both are vectors. When there are two vectors A and vector B, if they are perpendicular to each other, what does that mean? It means the effect of one vector on the other vector will not be there. There is no effect of one vector on the other vector if they are perpendicular to each other. It means the acceleration vector cannot change the magnitude of velocity. Similarly, the velocity vector cannot change the magnitude of acceleration when they are perpendicular to each other. So it means magnitude of velocity will not be changed by the acceleration of the particle because it is perpendicular to the velocity. So this type of motion is called as uniform circular motion. This is called as uniform circular motion. Now, if theta is less than 90 degree, if theta is less than 90 degree, let us say this is the direction of velocity and this is the direction of acceleration. So what will happen? One, if we resolve acceleration into two components, one is along the velocity direction, other is normal to the velocity direction. Along the direction of velocity will increase the velocity, magnitude of velocity, that is accelerated motion, and perpendicular to the direction of velocity will change the direction of motion. Here we can say magnitude of velocity will not change by the acceleration, but yes, direction of velocity will change when the velocity and acceleration are perpendicular to each other. So it means it is accelerated motion. This is accelerated motion along the curve. And if it is greater than 90 degree, when velocity and acceleration are making angle which is more than 90 degree, then one component of acceleration is opposite to the velocity, another component of acceleration which is perpendicular to the velocity. So the component of acceleration which is perpendicular to the velocity will change the direction of motion, direction of velocity, and the component of acceleration opposite to the direction of velocity will decrease the magnitude of velocity, which means it will be retarded motion. Retarded motion. So if either theta is less than 90 degree or greater than 90 degree, we can call this type to be motion along a curve, which is also known as curvilinear motion. We can call it as, it will not be along a straight line. The motion of the particle will be along a curve. Now there is another approach to analyze the curvilinear motion. We are going to talk about the curvilinear motion. So as we have already discussed that when there are two vectors which are perpendicular to each other, there is no effect of one vector on the other. Right? So because two perpendicular vectors are independent of each other, so this motion in two dimension or the curvilinear motion can also be resolved in two perpendicular direction to one dimensional motion in mutually perpendicular direction. So this method is called as, the method number 2 is by resolving of the curvilinear motion into one dimensional motion in mutually perpendicular direction. So this is where we are going to utilize, or where we are going to study the projectile motion. Look, this is our x direction, this is our y direction. When a particle is thrown some initial velocity, u, which is making an angle theta with the horizontal, this is horizontal direction, and this is, let us say, vertical direction. When a particle is thrown with some initial velocity u making an angle theta with the horizontal, so the motion of the particle under the effect of only the Earth's gravity or gravitational force is known as projectile motion. So if we resolve this motion, this is the curvilinear motion, we can call it as projectile motion. U is the initial velocity of the particle, theta is the angle which the velocity is making with the horizontal. Now, if we resolve the motion in x direction, so the component of initial velocity in x direction, that let me call it as ux, is equal to u cos theta by resolving the vector, and the velocity, initial velocity in y direction, component of initial velocity in y direction will be, let me call it as uy, is equal to u sin theta. These are the component of velocity. So x direction initial velocity is equal to u cos theta, and the acceleration is only due to gravity, which is in downward direction. So there is no effect of, or there is no component of acceleration due to gravity along horizontal direction. So we can say acceleration in horizontal direction will be 0. And when acceleration is 0, then we can say the final velocity in x direction will be same as initial velocity in x direction, that remains constant, that is equal to u cos theta. This type of motion is known as uniform motion in one dimension. It is called as one dimensional uniform motion. When the motion is uniform, we can say the displacement in x direction, the distance traveled by the particle in x direction, is equal to ux into t. This is the component of resolving the motion in one x direction along y direction. So along y direction, initial velocity of the particle is u sine theta. Acceleration of the particle is equal to minus g, that is constant. If the acceleration is constant, we can call it as uniformly accelerated motion. It is uniform acceleration. In y direction, it is uniform acceleration. And if it is uniform acceleration, equation of motion are easily applicable. If we apply equations of motion, then we can write then Vy is equal to Uyt plus half Ayt square. So it will give us the final velocity at any time t is equal to Uyt, that is u cos theta. Uy is equal to u sin theta, u sin theta into t minus half gt square. And we can also write the distance traveled in y direction by the particle in time t. So, the Vy, this is the formula for the displacement. Vy is equal to Uy plus Ayt, this. So it will be u sin theta minus gt is the velocity, final velocity or velocity of the particle after time t. Sy is equal to Uyt plus half Ayt square. So we can write it as u sin theta t minus half gt square, that is the distance traveled by the particle or displacement of the particle in y direction in time t. This is uniform acceleration, motion of the particle in along y direction will be uniformly accelerated motion. Motion of the particle along x direction will be uniform motion, right? Now from here we can find some values. This is y direction, this is x direction. The particle will move in a projectile motion like this. So first of all, let us find out the maximum height attained by the particle when the initial velocity of the particle is u, making an angle theta with the horizontal. So can we say that at the highest point, particle will have only horizontal velocity, that is ux, or we can call it as vx is equal to u cos theta. There is no velocity in y direction at the highest point. We can say Vy is equal to 0. So from this condition we can say Sy will become h if Vy becomes 0. By using equation of motion, Sy is equal to Uyt minus half gt square, or we can use the another expression, which is Vy square minus Uy square is equal to 2 into Ay into Sy. If we put the values, Ay is equal to minus g, so that will give rise to 0 is the final velocity in y direction, minus initial velocity Uy square is equal to minus 2g h. Sy becomes h. So from here we can say h will be this negative will get cancelled out, Uy square by 2g. If you analyze this expression, it is very much similar to the highest or the height attained by a particle when it is thrown in upward direction with the velocity uy. U square by 2g is the height attained by the particle when it is thrown in vertical direction. But because the component of velocity in y direction is uy, that is why we are getting uy square. So it is u square sine square theta by 2g. That is the maximum height attained by the particle. When the particle is thrown in such a way that it is making an angle 90 degree, for theta is equal to 90 degree, it is vertical motion. There is no horizontal component of motion. So when theta is equal to 90 degree, sine theta is equal to 1. So we can say h will have its maximum value when the particle is thrown in vertical direction, that is u square by 2g. That is what we have got when we analyzed one dimensional motion under gravity, vertical motion under gravity, u square by 2g, right? Now this expression can also be obtained, by using the energy conservation. Why we can apply the energy conservation? In work, energy and power, we are going to study that when the work is done only by the conservative force, no other forces are involved, then the total mechanical energy of the particle or an object or the system remains, system of particles, it can be system of particles, will remain constant, because the only force acting during the motion of the particle, it is mg, which is gravitational force, which is conservative force, because the only force acting is conservative force, and that is the reason the motion of the the energy conservation or mechanical energy conservation can be applied. If we apply conservation of mechanical energy of the particle from point 1 to point 2, let us say, between point 1 and point 2, for potential energy, you know, we need a reference line. So the potential energy of the particle at point 1 will be 0. It is 0 plus the only energy is the kinetic energy, half mass of the particle is m, then u square, or we can write it as ux square plus uy square, because u square is equal to ux square plus uy square, is equal to, if we talk about the highest point, there is no velocity in y direction. So the potential energy of the particle is mgh plus half m ux square. There is no change in the velocity along x direction because there is no acceleration of the particle. So if we simplify this ux square will getting cancelled out with this term, m will get cancelled out with this m. So it will be uy square, h will be equal to uy square by 2g. That is another way of getting the same expression, because the work is done only by the conservative force, right? Now, whatever at initial point, the only energy is kinetic energy. But as the particle moves up, there is an increase in kinetic, there is an increase in potential energy. Potential energy at the reference line is 0. We can say if the particle is moving above the reference line, there is an increase in potential energy. So if there is an increase in potential energy, it must be gain in potential energy, which must be at the cost of loss in kinetic energy. So we can say gain in potential energy up to this point is same as the loss of kinetic energy between these 2 points. Now, because the velocity is minimum at the highest point, at highest point we can say velocity is minimum. at the highest point, velocity is minimum, so we can say kinetic energy will also be minimum, or we can say potential energy will be maximum, because the sum of total mechanical energy should remain constant. Total mechanical energy of the particle remains constant. So there may be a question that what is the minimum kinetic energy of the particle? We must know that the minimum kinetic energy is possible at the highest point. So the value of minimum kinetic energy, can be written as half m into u cos theta square. That is the minimum kinetic energy which is at the highest point. Now we can also calculate the time of flight. We can also find out the time of flight of the particle. That the time traveled by the particle in air is called as time of flight. So can we say the time taken the particle when it again reaches at the horizontal position, then the time taken is called as time of flight. So we can say if Sy becomes 0, the displacement of the particle becomes 0, then the time taken during this motion of the particle is called as time of flight. So we can use the equation of motion, which one is Sy is equal to Uyt, plus half Ayt square. So when Sy becomes 0, Uy into time becomes capital T minus half Gt square. If we take T on the other side, or if we take T common and send it to the other side, so T will be equal to 2Uy by G. It is same as the time of the flight when the particle is thrown in upward direction. Then the time taken by the particle to reach again to the ground position is 2U by G, because the particle is having Uy as the component of initial velocity, so it will be 2Uy by G, or we can say 2 into U sine theta by G. That is the time of flight. Now from the symmetry we can easily say time to reach highest point will be half of time of flight. So time to reach highest point is Uy by G, that is equal to U sine theta by G. T dash is to reach highest point. The time to reach highest point. Clear? Now we can also find out the horizontal range, the horizontal distance traveled by the particle during the motion, during the entire motion. This distance is called as r, because there is no acceleration in x direction, because there is no acceleration in x direction. Ax is equal to 0. Because Ax is equal to 0, so we can apply the simple equation distance is equal to speed into time. So r will be equal to ux into the entire time of journey, that is the time of flight. So ux into time of flight can be written as 2Uy by G. So the range of the particle is 2Ux into Uy by G. If we put the value of Ux and Uy, Ux is equal to U cos theta, Uy is equal to U sin theta. So it will be 2U square sin theta cos theta upon G. 2 sin theta cos theta is equal to sin 2 theta. So the range is equal to u square sine 2 theta by g. That is equal to twice of ux into uy by g. But this range can also be made maximum. How to increase this range further? Either increasing the velocity u, initial velocity, or if the particle is thrown with the same initial velocity, if we change theta angle, then also the range can be changed. So for 2 theta to be 90 degree, or we can say theta is equal to 45 degree, sine 90 is equal to 1. So R will have its maximum value, that is equal to u square by g. When theta is equal to 45 degree, when the particle is thrown at an angle 45 degree, then range will become maximum. When the particle is thrown at an angle 90 degree, then the maximum height attained becomes maximum, h max, that is u square by 2g. We have already discussed. So maximum possible range is u square by g if we talk about the same initial velocity, and which is twice of h max, isn't it? Maximum height attained can be maximized by throwing the particle in vertical upward direction, because h max will be equal to, we have already talked about that, u square by 2g when theta is equal to 90 degree, when the particle is thrown in vertical upward direction. So range will be twice of h maximum. Now from here, let us talk about some more interesting concepts. Look, this is going to be very, very important. Y and this direction is x. This is the projectile motion, right? Now look, when the particle is thrown, let us say this is the projectile motion. When particle is thrown with the velocity u, making an angle theta, then range will be equal to u square sine 2 theta by g. This is the range. Now can you tell me, R is equal to u square sine 2 theta by g. Can we say that for 2 theta and 180 degree minus 2 theta, sine 180 degree minus 2 theta is also 2 theta, sine 2 theta. So for 2 theta and 180 degree minus 2 theta, they are supplementary angles. For both of them, range will remain same. Or if we talk about the angle of projection, theta and 90 degree minus theta, for these two angles, these are complementary angles, we can say range will remain same if the initial velocity is same. So if we throw the same particle but making an angle 90 degree minus theta with horizontal, the velocity of the particle is still the same, then the range will be same for both these projectile motion, because theta and 90 degree minus theta are complementary angles. If we put the value of theta as 90 minus theta, then 2 theta will becomes 2 180 degree minus 2 theta, and the sine value of sine 2 theta and sine 180 degree minus 2 theta will be same. For these two angles, the range will remain same. This is, let us say, first motion. This is, let us say, second projectile motion. Can we write time of flight for the first motion? We can say 2 u sine theta by g. That is the time of flight when the angle of projection is theta. What about time taken by the projectile motion when it is thrown within with the angle of projection as 90 minus theta? So it will be 2u sine 90 minus theta. Theta and 90 minus theta are complementary angles, so it will become 2u cos theta by g. If we divide these two, T1 by T2, 2u by g getting cancelled out, then it will be tan theta. We can find out that angle of projection such that the range becomes same. Theta and 90 minus theta, we can easily get, sorry, it is tan inverse of T1 by T2. Isn't it? If we square T1, T1 square is equal to 4u square upon g square, then sine square theta. And what about T2 square? T2 square is 4u square upon g square cos square theta, isn't it? If we add these two, T1 square plus T2 square will be equal to, if we take 4u square by g square common, then sine square plus cos square theta, which is equal to 1. So it will be 4u square by g square. So u square will be equal to g square into T1 square plus T2 square by 4. So from here we can say the initial velocity can also be calculated as under root of g square is g, under root of 4 is 2, then under root of T1 square plus T2 square. I hope this is clear. Similarly, for the same diagram, you can write H1. This is, let us say, H1. H1 will be equal to, what is H1? H1 will be equal to u square sine square theta by 2g. That is H1. And what about H2? H2 is equal to u square by 2g. Then in place of theta, if we put 90 minus theta, sine 90 minus theta is cos theta. So it will be cos square theta. If we add these two, or if we divide these two, H1 by H2 will be equal to tan square theta. So from we can find out theta is equal to H1 and H2 are the maximum height attained. Theta is equal to tan inverse of under root of H1 by H2. Theta will be equal to tan inverse of under root of H1 by H2. If we add these, H1 plus H2 will be equal to u square by 2g. Sine square plus theta plus cos square theta will be equal to 1. So from here we can also find out u is equal to under root of 2g H1 plus H2. This is u. If we multiply h1 and h2, look, if we multiply h1 and h2, so it will be u square by 2g whole square, then multiplied by sin square theta into cos square theta, isn't it? So can we write it as u square by 2g into sin theta into cos theta? We can write it as whole square. If we multiply and divide by 2 whole square, I don't think there is a problem. Now u square sin 2 theta by g, if we see this much, that is r, isn't it? U square 2 sin theta cos theta is sin 2 theta upon g is r. So we can call it as r by 4 whole square. That is equal to h1 into h2. So r will be equal to 4 times, the range will be equal to 4 times under root of h1 into h2. That is the relation between range and h1 and h2 simultaneously. I hope this is clear. So these are some of the formula which are important in analyzing the projectile motion. Next is equation of projectile motion. Equation of the projectile motion. As we know, what is equation of the projectile motion? That is the relation between x and y. This part we are going to discuss in the next session. All right. So we will discuss some numericals as well along with this, along with the remaining concept of projectile motion. So see you in the next session. Till then, enjoy, take care, have a great day.